In this lecture, we are going to see how good the rays are converged by convex lens when kept in different medium. Converging action of convex lens. See, already we have seen a lens maker formula 1 by f is equal to, for f stands for focal length of a given medium. 1 by focal length is equal to refractive index of second medium by refractive index of first medium minus 1 into 1 by radius of curvature of first surface minus 1 by radius curvature of second surface. So in case if the lens is kept in air, this is glass, this is air, this is medium 1, this is medium 2. In this case, we want to find out what is the focal length of the lens when kept in air. So this is equal to mu 2. The mu 2 is this one, refractive index of glass divided by refractive index of the medium 1. Medium 1, that is air minus 1 into 1 by R1 minus 1 by R2. So this is the refractive index of, or we can say this is refractive index of glass with respect to air minus 1 into 1 by R1 minus 1 by R2. 1 by R1 by 1 by R2 is a positive quantity because R1 is this is surface 1, this is surface 2, this surface spherical surface. R1 for this will be here, this will be R1. So the distance from here is positive, along the ray direction we are measuring positive. It means R1 is equal to plus R1 and R2, this surface, this is R2. So we are measuring from here to here. Therefore, R2 is minus R2. When put in this equation, this becomes 1 by R1 minus 1 by R2 is equal to, with sign convention, 1 by plus R1 minus 1 by minus R2. So this becomes 1 by R1 plus 1 by R2. So R1 is a positive quantity, 1 by R1 is also positive quantity, R2 is also positive quantity, and 1 by R2 is also positive quantity. Positive quantity added with the positive quantity will be positive quantity for convex only, for convex lens. We are dealing about convex lens. Therefore, 1 by FA, this we are dealing when the refractive index of the second medium is greater than refractive index of the first medium. First medium, second medium is glass, second medium may be air, water, whatever may be. So 1 by is equal to refractive index of glass with respect to air minus 1 into 1 by R1 minus 1 by R2. So same, when the same glass is kept, R1 R2 remains same, only it is kept in, say, water, liquid. So this is medium 1, this is medium 2, surrounding medium, when surrounding medium is liquid. So focal length of this lens when kept in a liquid. When kept in a liquid, what will be the focal length? 1 by focal length of the lens when kept in liquid is equal to refractive index of second medium is glass, refractive index of second medium, that is glass, divided by refractive index of first medium is liquid minus 1 into minus R1, 1 by R1 minus 1 by R2. There will not be change because the lens is same and its radius of curvature is same. So this is a positive quantity, or we can say refractive index of glass with respect to liquid minus 1 into 1 by R1 minus 1 by R2. This is, you can say, second equation. and this is our first equation. This is first equation. So we will divide equation 1 divided by equation 2. When dividing, this will become one focal length of lens in liquid. Focal length of the lens in liquid divided by focal length of the lens when kept in air is equal to this, and this will get cancelled when dividing. This and this will get cancelled. Then this FL is 1 by FL means this is in the numerator. FL means this will be in the denominator. Check up. So this will be like this. Refractive index of liquid with respect to glass -1. Refractive index of glass with respect to air -1. Say if the liquid is water, it means its refractive index of water is equal to refractive index of liquid. See, if we are having water, is equal to 4 by 3, which is equal to 1.33. Refractive index of glass is equal to 3 by 2, which is equal to 1.5. Now, refractive index, so what will be this one? Refractive index of, this is refractive index of glass with respect to air is equal to 3 by 2 divided by 1 minus 1 is equal to half. 3 by 2 is half. 1 and half minus 1 is equal to half. Refractive index of glass with respect to refractive index of liquid, that is refractive index of glass with refractive index of water is equal to 3 by 2 divided by 4 by 3 is equal to 3 into 3, 9 by 8. So refractive index of glass with respect to refractive index of liquid is equal to liquid minus 1, this factor, this one is equal to minus 1 is equal to 9 by 8 minus 1 is equal to 1 by 8. So this is equal to 1 by 8. This we have find it out of, this is equal to 3 by 2 by 1 minus 1 is equal to half. So we can write focal length of glass by focal length of the same lens in air is equal to, this is equal to half, and this is equal to half 1 by 8, which is equal to, the 8 will go on the top, 8 will go on the top, 2 will come, is equal to 4. That is, focal length of liquid is equal to 4 into focal length of air. Focal length in air, it means the focal length of liquid is greater than focal length of air. In this case, what you can see, since focal length is more, this is the lens when it is kept in air. So this will be the focal length. Converging action, because it acts as a converging lens when the refractive index of the second medium is greater than the refractive index of the first medium. This is ray. So this is equal to focal length of the lens in air. And in water, the same lens, it is kept in water. So it will have, since the focal length is more, it will come like this. The focal length, this is focal length when kept in water. It means we can see this has got more diverging. It bends the ray much more than this. When the same lens is kept in water, this is the focal length. In that case, what happened? This has got more converging power. The bending of the light, here the bending of the light will be like this. For air, it will be like this. For air, it will be like this. The converging of, for this one, for water, it will be like this. It means the focal length is greater. This is the effect. It means the focal length of any medium, if you kept a surrounding medium as water and surrounding medium as air, the focal length of the same lens in air will be less than the focal length of the same lens when it is kept in any other liquid whose refractive index is less than the refractive index of the glass.